we can start with the new talk. A Soldatenko, we talks about building serverless applications with Python. Thank you, Andriy.
Thank you. Good morning, everybody. Thanks for attending my talk in this morning. And today I'm going to speak about how to build and deploy applications written in Python using serverless approach. About me, briefly. My name is Andriy Soldatenko. I'm from Kyiv, Ukraine. I'm one of the organizer of PyCon Belarus. I have my own startup and I work in the TopTel. And I like freedom, that's why I work mostly remotely. In next few years, we are going to see the first billion-dollar startup with a single employee and co-founder and the CTO, and it will happen by using serverless technologies. It's a great quote by James Gower, and I start from this quote. Let's think a little bit about origins of serverless. Serverless is a new trend of the software development. It's confusing many developers around the world. It's like a Docker when it first launched and nobody tried it, but in a couple years it's super famous. And let's try to find the origins of this term. First time Ken Form in 2012 used this term in his article. And later, another developers mentioned that he also heard about usage of this term in context of continuous integration. Good example, when we have Travis CI and we delegate continuous integration and testing of your project to third parties, and we not care about setting Jenkins, configure jobs, etc. We just use one YAML file and we can run, for instance, tests. It's from real projects that I've contributed. Later in 2014, Amazon Web Services announced Amazon Lambda. And as a result, in 2015, we see lots of usage and provisioning of this idea. And it started in October 2015 in the reInvent conference. We had talked with title the serverless company using AWS Lambda, and it's a real big example of production usage of this idea. As in any new technologies like a Python, what about conferences? Is a new technology, but it already has a conference. It's called Serverless Conf. It's in a couple countries. But let's think a little bit how Lambda works. How many of you have used Lambda at his work? Can you please raise a hand? Oh, it's quite a lot. Okay. Let's do quickly. And AWS Lambda is different from traditional approach because AWS Lambda executes your function on your behalf and run it in containers, what you really needed. And Lambda can look like this for me, especially. It's a good scheme where you can find very simple example how you can work with Lambda function. You just create a function, you provide an event and a context, and then you have a result. Lambda function life cycle is like near 40 milliseconds, for instance, if it's like just for one request. How Lambda works? What you really need, you can go to AWS and then create new function, you select name, you select memory size, timeout, role, whatever. I think it's very easy. One note that when you choose, for instance, 256 megabyte of memory, it's allocate approximately CPU power to your Lambda. And it's like in all AWS services, you can play with these sizes. Perfect. Let's do small coding. It is the simplest Lambda you can imagine, and it's just 3 lines. You should declare your handler. As I said previously, you put as a args is an event and a context, and you just return something. Then what you really need, I create small bash script where you can create zip file and create function. As I mentioned previously, you put function name, zip file, role. You should already created this role before. You declare handler, you set up timeout, memory size, etc. And you can do it by graphic user interface, but I prefer command line tools. It's faster for me. Okay, and how you can run this function? You just can also do it manually from UI, but I prefer bash. You can do using AWS command line tool. You just run invoke. It's the simplest one. You select your function name, you put payload, and then you see that some output file returned, and you can see that it's like hello world by PyCon Italy. Yeah, but it's interesting, but it's super trivial, and we live in real world, and we need to solve real problems. And one of the big problems that you can solve using AWS Lambda, you can create some RESTful API. And what you really need, it's another AWS service which called API Gateway. The idea of API Gateway is just you can create proxy between some routes to your Lambda functions. For instance, you can create AWS Lambda function getBooks, and you can map it in AWS API Gateway to URI books, and it will work. And also, when you do it manually, you can set up tons of stuff. If you've done it before, you understand me. If not, you can try. Like, for this simple example, you will spend like 20 or 30 minutes, I think. Also, you can select verbs. It's not mandatory, but you can put all. It means that this resource will work with all HTTP verbs. Not all from HTTP RFC, but like from 7 or 8 lists, like get, post, put, delete, and another. How to manage it, how to do it more easily, and the answer goes from AWS Labs. One tool I appreciate for its simplicity is Chalice. I'm one of the contributors of this library. It's super simple, and you can do all the stuff that I mentioned in previous library quickly. And it's currently published as a preview. It's not required to use in production because it's version like 0.7, but when version 1.0 will release, we can, I think, try it on production. And Chalice works for Python runtime as a syntax of Flask and Bottom. And you just need to create simple app.py and pip install this library. And you can see my previous example, you just register routes like you do in Bottle or in Flask, and it will work. And Chalice under the hood will create all necessary stuff. It creates AWS Lambda function, it generate API routes for you, it create API gateway mappings, it will create EM role, etc. But not everything. And for another example, if you need more stuff, you need like this code. I don't like such kind of code, but it's one of the possible way how to do it, and probably we will improve it later. Okay, and what you need next, you just need to do Chalice deploy without all the stuff that I showed previously. and Chalice will create zip file, as I said, create aim policy, create Lambda function, deploy it, and generate link where you can test your API. And what's interesting, Chalice is also experimenting with inspecting the code and find AWS resources that you need to access. For instance, S3 buckets and other stuff. I mean, you can try and check documents or source code, whatever. Just to prove my words and concepts, you can see that everything works. You do GET request to books, you see books, you can get a specific book with ID 15, you return book 15, whatever. I mean, you can do whatever you want. You can inject SQL alchemy, create user with real database. It's easy. Or do any logic that you need. One of the feature list that I prefer of Chalice, it's still small, but you can do lots of stuff. Like you can handle your errors, you see logs in CloudWatch, you can request metadata, you can add cross-origin request support, and another. Okay. Under the hood, developers use only Botocore. It's written in Python 2.7, unfortunately. But we use typing, and it's cool. I mean, it's one of the coolest projects where you can find a real example of typings. It's a new feature of Python 3 and backported to Python 2. But not everything's so smiley, and we have issues that Chalice can't delete all stuff that you create. For instance, if you play with it or you need very fast, redo everything that Chalice created, you need spend time. And we have issues that I'm trying to edit. One of the contributors raised it, that it will be great to do Chalice delete, and it will go to AWS and remove all this stuff like Lambda, API gateway, aim policy, whatever. But it's still, as you see, it's still not implemented, it's still open, but probably it will release in next couple months, but I'm not sure what the AWS Labs team not always accept lots of help. They just also maybe busy. And one of the blocker, it's course developers of Chalice decided to not implement only delete. They tried to implement SAM. SAM is serverless application model. It's released, I hope, in 2000, last year. And it's what is it? Extends AWS CloudFormation to provide a simplest way of defining the Amazon API gateways and AWS Lambda function. And for instance, database if you need it. And you can, what the advantage is, if you use SAM, you can redo everything very quickly because you have file where you describe all resources. And because now if you need to delete everything, you should know each name that generated, because you can by mistake remove something that not related to your AWS Lambda. And this idea allows you to easily create, manage resources using JSON or YAML and whatever. I mean, you can find official document with examples and proof of concept. We have very big requirement for that, and I hope it will release soon in Chalice. But we are developers. We need solve real problems as I return back. And first that I found that we have limits. We have limits everywhere. And limits of Lambda is you have only half gigabyte space, you have only 1,000 open descriptors, execution time is limited by 5 minutes, etc. And it's pretty small. You can do first 1,000 requests for free, and if you use one lambda with 1 gigabyte of memory. And you can proportionally divide this time if you use more lambdas, but it's pretty enough to start playing with it and doing. And it's cheaper than Heroku or in other providers. I'm not a vendor of AWS, no. But I'm thinking because sometimes you and me have simple problems like you need Slack bot, but you don't want to pay $20 per month or whatever. You need something tiny, and it's a great example when you can deploy, create Lambda just for notification about deployment or do some interesting pictures to a Slack channel, etc. That's why I'm trying to focus on it. But what about if you try to run Django or another WSGI applications? Do you have ideas how to run it on AWS Lambda? Nobody? Okay, perfect. It's Zappa. Zappa make it super easy to build and deploy all Python stuff. And it's, by design, it's the same as Chalice, but it's try to run all this big stuff from Django and host it like your Python app. One of the interesting findings, Zappa is on the first place of the top 10 Python libraries of 2016. It's pretty famous. I mean, there are lots of stars in GitHub, there are lots of activities, and it's very fast growing community, and yeah, it's cool. And again, what do you mean about serverless? This word is still confusing. Okay, but it only has 40 milliseconds lifecycle, and it means without any permanent infrastructure. Problem that with a traditional HTTP server, the server is online 24/7, processing requests one by one. If a queue of incoming requests grows large, you have latency, and your application responds too slow, like you can see on peaks, like 6 seconds or whatever seconds. But what Zappa and AWS Lambda under the hood do, each request is given and stored as a server by API gateway and run. Each request run in separate Lambda, and it do super quickly, and you pay only for time. Like if you have 2 users per day, you pay like nothing. If the load is growing, you can like pay only for the requests. And it's super cool feature to save money and to scale. Because if you use traditional synchronous approach with Django, Supervisor, Unicorn, etc., you need to think what you do. You should clone your application instances, you should do Redis cache, but it's still synchronous app, and you can't, you have limits. But in this idea, you can do it very easily and scale. The semantic of Zappa the same as for another like Chalice style. You can just install it, you can init, you can deploy. I mean, you can try tutorial videos. I mean, unfortunately, we have no time to go digger to Zappa, but I hope you can find it interesting. And briefly, I can explain some usage of Zappa. One of the cool features, you can tail logs. You can run whatever manage commands from Django or create manage similar commands in Flask with Flask manage. You can do rollback, you can run separate tasks like celery, you can undeploy, etc. There are lots of bunch of stuff that you can do without with Zappa. Okay, but we now live in 2017, and AWS supports only these runtimes. And Node.js guys more lucky because they upgraded to one of the latest versions. But we still work with Python 2.7. But like last 2 years, I work only on Python 3 projects. I don't like to write code in Python 2.7. And I like to write in Python 3 in production. By the way, who from what of you use Python 3 on production? Okay. another use Python. Why, guys, are you afraid to migrate Python.3? Do you have ideas? Like money, yeah. Okay, I have solution for you. I think it will be a little bit laughy for next couple minutes in this Saturday morning. For me, it's but why. Why we should live in Python 2.7. Python 2.7 will retrieve in next 3 years. And it's a big fact that you can speak with your customers. In next 3 years, there is no any support of Python 2.7. And we still, clock counts down until 2020, April 12th, it will be PyCon US, and we, as you can find on internet by this link, Guido said that we are going to shut down Python 2.7 on PyCon US in after 3 years, and it will be super funny event, and I'm going to attend and recommend to you guys. Okay, but what if you want to run your Lambda in Python.3? And we need to find out a little bit about the environment. I like to know about Linux machine where I work. I am backend developer. I don't like just, serverless is a cool feature. You like outsource something to third-party providers. But sometimes you need to know where you work, because if you have some issues, you need to go and dig into it. It's like with Heroku. If you run Hello World app, everything perfect. If you run something more bigger, you get stacked, because one of the examples, you want to install extension for Postgres using Heroku. You need to pay money. Yeah. And this is where the Lambda code editing is really helpful. I mean, if you go to AWS Lambda website, you can do like online editing your function, and you can do some discover like I did. And I will show you what I've done. Like, I created super simple Lambda function, and I tried to check, because I imagine that it's probably EC2 VM or something like it, or Docker in VM or whatever. And I want to know what is it. And I tried to see what's issues, and it's super cool. Yeah, I just tried to read the file. Yeah, and it's just Linux, and it's working. I mean, I can read some Linux files, etc. Perfect. What about better check in depth? What's your name of the machine? Because it means that I can compile something and it will be compatible with this machine. Okay, do the same. Like, subprot is my friend, and like I can run any bash script. It's uname -a, whatever, rm -rf, whatever. I mean, I didn't do it, but you can try. Okay, it's just, as I said, it's just Linux VM machine with like 64 bits. Perfect. Yeah, and it's this pretty standard 64-bit Linux directive. Okay. Success. We answer. Okay, now we have enough information to know how to run our Python 3 code inside this AWS Lambda. And the answer is very simple. Which Python.3? And how do you think what the output can be? Do you have ideas? Okay, can you please repeat? Okay, any other ideas? Can you please louder? Yes, you're right. It's here, and you have Python 3 inside Lambda. And
after this talk, they are going to close this opportunity.
Yeah, please take down the slides.
No. I mean, it's common trick. I mean, you can't close it. If you close it, I mean, if you hard code it.
Just uninstall Python 3 from.
Yeah, please do. I mean, okay, but it's still Everything okay, and we can build everything and run, yeah? Now we have got our build machine. And, oh yes, we need to invoke Python 3 from Python 2, forgot mention a bit. Okay. It's something strange. You need run Python 3 from Python 2, and it's in Russian, but you can translate it about David Blaine. I don't know, is it Italian translation, but you can try. Okay, what can we do? We just create virtual env, and it's a good example how you can build your own something that you need inside Lambda, not just def handler Lambda run or print or whatever. You can create virtual env. You can install any requirements that you need except binaries. It's another my slides. And you can zip everything that you program and your virtual environment and whatever you want, and you can just, it's one line by the way. And like I have Python 3 program and I have my Lambda, it's inside my function. And something goes strange. Yeah, and you can run it and it will work. And as a proof, I just print Python version in the logs and it's working. But one problem that we can't send data from Lambda to internal Python 3 script, except if you put arguments to your code, like you do in subprocess, open, etc. And you can do. It's quite tricky, but it's like we said in the dev community, it's a workaround. To fix this, we can use also another workaround. It's cpickle. For instance, you can, in your main program, you can create cpickle file, but you should keep in mind that this file should be not in the same directory. It should be in the temp directory that I showed in the previous slides, where we have 512 megabytes memory, but it's a different story. Okay. And thanks this guy for ideas about hacking. I rewrite his very, very old article with my examples, and it's really cool. I think you will not do running Python 3 inside Python 2 in AWS Lambda, but it's I think, great starting of this morning, and you can understand and go deeper what you're working, not just like run something by tutorial and think, oh, okay. But usually when customer asks me to do something, it's usually something more not so straightforward. And last but not least, it's future of serverless. And one of the great point, it's like we still wait SAM implementation in, for instance, Chili's. But you can use SAM already without by hand. It will, for me, it looks like Docker Compose. You can think very similar. You can like just describe by sections your function, your API gateways, your database, and it will work as a one big compose, like compose of Docker containers. The biggest problems of serverless and other function as a service, also unfortunately I have no time to dig deeper about this term. It's like separate talk, but right now it's tooling, and you still need do lots of job. You need deployment, you need configuration, monitoring, debugging. If you need a new library, you should recompile it, create zip file, redeploy. You still have some tricky things that you need to put in this zip file. If, let's say, you want to use Pillow, you need to compile it. You need to compile it locally, put with Python bindings in this zip file and bring it to AWS, and it's still serious work. But yeah, but this document describes about SAM and how it can help us. And thank you for this morning. And if you have any questions, go ahead. Yeah, please.
We are a lot of time for questions.
Yes, I have a question. I didn't use Lambda, but I have read in several
Serverless.
several discussions and forums that AWS Lambda functions have different, let's say, warm up or boot up time. For example, the first time that you invoke a function, it's slower, and then it's like cached or already warm
indeed.
up. So there is this unconventional, let's say, performance problems that you have to face, that maybe you should sometimes invoke the function to keep them warm up or something
You
like
answer
that.
to your question. I mean, the term is called warm your Lambda. I mean, Zappa and Chalice, I think, yes, but I need to check, support some flags. When you deploy your Zappa, your Lambda, you can like run small like pinger, which will ping your function. It's needed only if you need like your application running 24 hours to 7 days per week. Yeah, it's issue. Yeah, but I mean, because it's another idea, and it's more, Lambda is cool when you have really big load. And if you like have two users, like Heroku does the same. Like if nobody touch Heroku application, you will, first load will be like, I don't know, a couple minutes. Yeah, but yeah, it's a problem.
Okay.
People who are used to developing web apps in a normal server environment are also used to deploying a database and persistent storage. Are there any solutions in the serverless environment which don't then transfer your costs from your compute instances to your permanent storage or database? Are there any workarounds?
I mean, you need AWS Lambda itself can support another services. What is the big advantage is it's from scratch support all, not all, but some services. And you can use, for instance, DynamoDB or Postgres instance, and you can just, and from when you run AWS Lambda, it already installed Bota Core or something like it. I mean, you can invoke some API functions from the whole AWS infrastructure, and you can connect to DB or whatever. If you prefer Postgres, you need driver and you need compile it, etc. But it's already done. I mean, you can find the zip file and use it. It's very easy with Postgres, but it preferred way to use DynamoDB or something where you can just go through HTTP or some another provide without any third parties. Yeah, it's only, yeah.
Okay, another question?
I somehow missed how to deploy an application. Say you have something, a Django, which is running locally. How can you just deploy it on AWS?
Lambda?
Lambda, yes.
Zappa can help you. I mean, Zappa is a big framework where you can declare everything. If you're asking about nuances, yes, it's presented. You need to use S3 storage because collect static won't work. It's the same as you use with Django storage. Second, you need database adapter. It's like Postgres or whatever. You should put it together with your Lambda function. And you should store your code. Usually it's done by S3, but you can do it inside Lambda, like I did. I show you. I mean, I have not this slide, but when I play with all this stuff, 1 second. Not this slide. Yeah, I mean, I tried ls-la, and you see it's like just folder, and you put this code, and it will work. I mean, you can dig into Zappa and find it. I mean, it's very complicated to answer the whole nuances how Zappa do it. But you have limitations. It's not any Django app you can deploy. Not. I mean, you should because it's tricky with WSGI, because we run Django inside something like Unicorn, and it's a little bit tricky how to map it to API gateway. It's one of the limitations. Yeah. Yeah, and if you want to freedom and work remotely, go ahead. We work in Italy also.
Hello, I have a question about using this with Postgres.
I don't see you, sorry.
Waving over here.
Okay.
Okay. So how do you handle rate limiting when lots of requests come in and you're using, say, lots of Lambdas and a single Postgres server?
Yes.
Because when I'm using, say, Postgres and 3 app servers, I know more or less what my maximum capacity is. And I know that I will not overwhelm my database server with too many connections. Now, if I have a system which essentially creates a new server for every request, then there's a risk that I can overwhelm my database with too many connections coming in from all these new app servers being instantiated.
You're absolutely right. But
and I know that I might be able to use PG Bouncer in the middle, but now I'm running servers, so I don't run servers. And I feel that there's got to be a better solution. And I wondered if you might have any other suggestions for doing something like that if I have to be using a relational database and then I cannot use Dynamo, for example.
Okay. I will try to point my ideas about... Yeah, you're right. But interesting that when you have typical application, the right graph of your load, when you load growing, you should not use Postgres. I mean, if your each request go to database, you guys do something wrong. And you should, I mean, there is no, but I can draw it. When, like, let's say, number of users growing, the number of requests to Postgres should decrease or be stable, and number of requests to Redis or another cache backend should growing. And the answer is very simple. You should Postgres as a typical application. Okay, you have PG Balancer, okay, then you have Redis or HProxy or Varnish, whatever, and each request go, and this proxy should resolve the situation. And if you request in typical app go to the backend, and let's say Unicorn, and it's create separate or thread, or it's another worker, and it's use some CPU bound. It's the same with Lambda. And if you open the doors, each request use Lambda and connection to database, you do something wrong. And it's the same problem with the typical app. If it's go to Unicorn, go to database, you do something wrong. Or your application need more capacity. It doesn't matter, serverless or with server, you still need capacity for CPU bound. Yeah, because you request do something, calculate something, that's why you need Lambda. If it's just get from cache and show for user, no need to run Lambda. I mean, you can create proxy where you can run Lambda by request. You can create very tiny backend with as an Nginx upstream, and it will run your Lambdas or not, depend on situation. And with Varnish, something like it. I mean, you can use the same approaches. It's just matter of if you have too many requests and you have capacity, but if you use typical application, you can't scale it fast, or if you scale it, you still pay money for this big server. Like you pay every time, because let's say if we talk about Linode, you pay per month, not per request. It's why Lambda cool. Lambda cool when you have like millions of requests, but very short life cycle, something like it. Yeah, hope I answer. Yeah.
Cool, thanks.
Go ahead.
There is any question? No? Okay.
Okay.
Thank you.
Thank you very much.